my dear students, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. Today I am explaining RENEET exam chemistry paper questions. Already last video I explained some questions. So now I continue the remaining questions in this session. The question is, the correct statement about peptides and proteins is: number 1. In alpha helices, the polypeptide chain is twisted into a left-handed screw through intramolecular hydrogen bonds. Number 2. Tertiary structure of proteins has 2 or more polypeptide subunits. Number 3. Only the proteins having a quaternary structure are biologically active. Number 4. In a beta-pleated sheet structures, peptide chains are held together by intermolecular hydrogen bonds. In that first option, in alpha helices, the natural alpha helices in proteins are almost always right-handed side but not left-handed side. So also hydrogen bonds are intramolecular, but handedness is wrong. The polypeptide chain is twisted into left-handed is wrong. Always it is right-handed side. So that is the correct. So that option 1 is wrong. Tertiary structure is 3D folding of a single polypeptide chain. Quaternary structure is arrangement of 2 or more polypeptide subunits, but not tertiary structure. So this is wrong. In the third option, that is, many proteins with only primary, secondary, tertiary structure are also biologically active. For example, myoglobin is biologically active, and quaternary is not required every time. So this is wrong option. So the fourth option is, in beta-pleated sheet structures, peptide chains are held together by intermolecular hydrogen bonds. In beta sheets, the hydrogen bonds form between different peptide chains of different parts of the same chain far apart. But in alpha helix, the hydrogen bonds are intramolecular. So the correct option is option 4. The next question given below are two statements. Statement 1. Oxidation of para-nitrotoluene with acidic KMnO4 gives an acid that is stronger than benzoic acid. Statement 2. Reduction of para-nitrotoluene with tin HCl followed by neutralization gives an amine that is more basic than aniline. Then go to that statements one by one. Para-nitrotoluene with the acidic KMnO4 gives CH3 converted into COOH, carboxylic acids, and NO2. Because of NO2 is electron withdrawing group, acidity is increases. So that is more acidic than benzoic acid. Para-nitrobenzoic acid is more acidic than normal benzoic acid. In second statement, reduction of para-nitrotoluene with tin HCl, NO2 become NH2, that is para-methyl aniline will form. So here methyl group is electron donor group, so that aniline basicity increases than normal amine. So para-methyl aniline is more basic than aniline. So both the statement 1 and statement 2 both are correct. So the correct answer is 2. The next question, identify the reactions which give aniline as the major product. First, benznitrile, cyanobenzene, when it is treated with lithium aluminum hydride. This benzonitrile, when it is treated with lithium aluminum hydride, that is strongest reducing agent. So it becomes CH2NH2, benzyl amine, but not aniline. So not form, aniline is not form. Then benzamide, when treated with KOH-Br2, this is Hoffman bromamide degradation reaction. Hoffman bromamide degradation reaction. Amide become amine. Even aromatic compounds also we can prepare. Amine become amine. Primary amines will prepared by using Hoffman bromide degradation reaction. So it will give aniline. Then nitrobenzene. Nitrobenzene treated with sodium borohydride. Actually, sodium borohydride is mild reducing agent. So nitrobenzene cannot be converted into aniline. If you want to convert nitrobenzene into aniline, either tin HCl we use, otherwise tin HCl, iron HCl, otherwise nickel hydrogenation. Then nitrobenzene can be converted into aniline. But here sodium borohydride does not be converted. Then amide. This is also amide. So here acidic hydrolysis of amide. So acidic hydrolysis of amide will give amine and carboxylic acid. Amine, that is H here, OH here. So it produces aniline. Aniline and carboxylic acid CH3CO OH is formed. So that aniline is formed in this. So the correct answer is B and D, option 3. The next question is 2 moles of an ideal gas undergo free expansion from 10 liters to 100 liters at 300 Kelvin. The values of delta system, delta S system and delta S surrounding are. R is universal gas constant. So here from this given values, so the number of moles N is equal to 2 moles. Then volume, free expansion, volume V1 10 liters, V2 100 liters. But actually for free expansion, that means expansion into vacuum condition, Q is equal to 0, W is equal to 0. So delta U also 0 for free expansion. Here temperature also remains constant for ideal gas. Free expansion is irreversible process. Free expansion is irreversible process. In this, but entropy is a state function. They are asking about entropy, delta S. Entropy is a state function. So we can calculate delta S by using reversible isothermal path. Reversible isothermal path. For isothermal reversible expansion of ideal gas, delta S system is equal to NR ln V2 by V1. So N value is 2, that is R into ln 100 by 10. So that is 2 into R. ln means 2.303 log 10. Log 10 1. So the value is 2 into R into 2.303. That is 4.606 R. That is delta S system. But in free expansion, delta S surrounding means here no heat will be exchanged between system to surrounding. Q is equal to 0. So that delta S surrounding is equal to minus Q reverse by T is equal to 0. So here delta S universe is equal to delta S system plus delta S surrounding. The value is equal to 4.606 because delta S surrounding is 0. So the correct option is option 1. The next question, the compound that cannot be obtained from the aldol condensation reaction shown below is. So for aldol condensation reaction, we required alpha hydrogens, at least one alpha hydrogen. So here 2 alpha hydrogens are there in this molecule, but this is without alpha hydrogen. So here in these 2 molecules, one is containing alpha hydrogen, Another one does not containing alpha hydrogen, so that we can make mainly two products. In the two products, one is self-aldol product, another one is cross-aldol product. First, once you check that question, in that here CO, here protons are there, here CH3 and CH3. First it is treated with a base OH minus, so it will take out that proton, it generate carbanion nucleophile, carbanion intermediate, it generate a carbanion intermediate. Further it is treated with a benzaldehyde, so it will move, then it will attack to this carbon, so it form here, this is bonded with this carbon, CHOH, pH will form. Then by heating, dehydration takes place. Okay, that is finally we can make that answer is here double bond CH and pH. So this is possible and this is also possible. So this is what cross-aldol product. This product is cross-aldol product. Then self-aldol product is there. So these two are cross-aldol products. Now self-aldol product. So here base take out this proton, so it generate carbanion intermediate, then it is treated with the same type of molecule, another molecule, same type of another molecule, so then it will move, it is bonded, so that it given that double bond O, this molecule bonded with this 5-member ring, then by heating it undergo dehydration, finally we can get the product is here double bond, then this is 5-member ring, this is 5-member ring, here CH3 is there, so this product is formed, but this product is not formed, so second option cannot be obtained. This is self-aldol product. The next question, the complex which has facial and meridional isomers, they given that pyridine and ethylene diamide. So we know very well Ma3B3 type compounds exhibit facial and meridional type isomers. For example, A3 and B3. So here this is A, B, B. So this is facial. These are present in one phase. These are present in another phase. This is facial. Any two compounds change their position, it will become meridional. For example, B here and A here, A, B, B. So this is meridional. So here out of that four options, chromium Py thrice and Cl3, Ma3B3 type molecule, Cr, pyridine and pyridine. So this is chlorine. So these and all present in one phase. So here this chlorine atoms also present in one phase. This is facial. By changing any two atoms positions, we can make that is meridional. For example, here chlorine, here pyridine, then here chlorine, here pyridine and pyridine. So this is what meridional. Meridional. So the correct option is second option. The next question, the numbers 17.0145 and 21.0235 were rounded to the three significant figures after the decimal point. The resulting numbers respectively are. So here the first number is 17.0145. Here the last removed number is 5. Then before the number is a even number. If even number is there, if it is last deleting number is 5, so before that even number is there, no need to change anything, write as it is that number. So this is that round off to the three figures after the decimal point. Then come to the point of 21.0235 molecule. Here also the last removed digit is 5, but before the value is odd number. If odd number is there, add +1 to that odd number molecule. In that 21.023, that is +1 we added. When we added +1, the 23 become 24. So the original value is 21.024. This is we rounded to three significant figures after the decimal point. So that 21.024, 17.014. This is the answer. Fourth option is the correct answer. The next question, the amount of carbon dioxide evolved upon complete combustion of 116 grams of N-butane is. Atomic mass, hydrogen 1, carbon 12, oxygen 16. So here we want to discuss about N-butane, that is alkane combustion. Alkane combustion. So we know here alkane combustion formula CXHY plus X plus Y by 4 O2 gives rise to XCO2 Y by 2 H2O. So here CXHY is N-butane C4 H10. Then 4 plus 10 by 4. 4 plus 10 by 4 O2 gives rise to, that is 4 CO2 plus 5 H2O. So 4 plus 10 by 4, nothing but 13 by 2. So this value is 26 by 4 O2, nothing but 13 by 2 O2. 13 by 2 O2. So C4 H10 plus 13 by 2 O2 gives rise to 4 CO2 plus 5 H2O. So C4 H10 molecular weight is 58 grams. So that is 1 mole. 1 mole. 1 mole butane produce 4 mole carbon dioxide. But here they given 116 grams of butane. 116 grams means that is weight by molecular weight, that is 2 moles. 2 moles produce how many moles of carbon dioxide? That is 8 moles of carbon dioxide. So 8 mole CO2. 1 CO2 is 44 grams. So 8 moles, 8 into 44, that is 32. 32 plus 4, that is 8 4 is 32. 8 4 is 32 plus 3, 35. 352 grams is the correct answer. So option 2 is the correct one. The next question is, consider the following schematic plots of orbital wave function against distance r from the nucleus. The figure representing two radial nodes. Two radial nodes. So here this is 1s orbital. So 0 radial node. So here how to find out radial nodes? So the curve overlap to that this 0 curve, this dotted line. So then only that represents nodes. For example, here first diagram 0 nodes. In that second diagram we have, this is the node, this is node, one node is there, one node. So here this is one, this is two nodes, but here this is only one. Here it is not overlapping this dotted line, it is present along with that dotted line, so that this is only one node. So that they are asking about two radial nodes. This is the two radial nodes, that is option C. Okay, now C is the C diagram containing two radial nodes. That's why option 4 is the correct representation. The next question, the following carbocation is stabilized by the interaction of the empty p orbital with. So here if you observe this molecule, here the carbocation is stabilized by adjacent methyl group, then adjacent pi bonding electrons. So here alpha CH sigma bonding electrons will move. So this is nothing but hyper conjugation. So it will give 3 hyper conjugations to nullify this positive charge. This is benzyl carbocation. In this benzyl carbocation, this carbon, adjacent carbon is called alpha carbon. This alpha carbon containing 3 hydrogens. So it can donate alpha CH sigma bonding electrons towards pi bond, and that is empty p orbital, vacant p orbital containing carbon atom. So here which electrons are moving? Sigma bonded electrons, that is filled sigma bonding electrons. Filled sigma bonded electrons will overlap towards vacant p orbital containing carbon atom, that is called hyperconjugation. But in this case the pi bonding electrons will move. In this case in the left, okay, now carbon, carbocation is there, here methyl group. To nullify this positive charge, these pi bonded electrons will move. This is called resonance, so that this carbocation can be stabilized by hyperconjugation and also with resonance. In resonance, which electrons are involved? Pi bonded electrons are involved, that is filled pi orbitals. So that here carbocation right side it is stabilized by filled sigma orbitals, left side it is stabilized by filled pi orbitals. So that the correct answer is second option. The next question is 1:3 electrolyte in an aqueous solution is. So in that compound A, for example, this molecule we added in that aqueous solution. So no ions present outside the coordination sphere. So outside the coordination sphere, what are the ions, what are the elements are present, that only dissociate. Inside the coordination sphere, here that central metal atom strongly bonded with these ligands. That's why not that much easy to dissociate. So that here zero ions, zero electrolytes will be released in aqueous solution. But here this chloride ion present outside the coordination sphere. So it can generate two ions. One is this coordination sphere, another one is chloride ion. But here 3 ions, that is one coordination sphere and 2 Cl minus ions. So total 3 ions are there in this molecule. Here total 2 ions are there in this total 3 ions. But here the coordination sphere, that is one molecule and 3 Cl minus ions and one coordination sphere, total 4 ions. So but they are asking 1:3 electrolyte solution. So that this is 1:3 electrolyte solution. So 1:3. So 3 ions it will be dissociate. 1:3 electrolyte solution. The correct option is fourth option. So this is 1:1. This is 1:1. This is 1:2. This is no ions are present outside the coordination sphere. So this is 1:3. The next question is the standard electrode potential E0 for the half cell reaction Fe+3 plus electron gives rise to Fe+2 at 298 Kelvin is. So the given Fe+3 to Fe, that is minus 0.04 volts, and E naught Fe plus 2 Fe minus 0.44 volts at 298 Kelvin. So that they given these values Fe plus 3, Fe plus 2 and Fe. So they given Fe plus 3 Fe, this value is 0.04. Then Fe plus 2 Fe value, that is minus 0.44. So to become Fe plus 3 to Fe, that means it required 3 electrons, n value is 3. Then Fe plus 2 become Fe, it required 2 electrons. Then find out Fe plus 3 to Fe plus 2 value. So we know that E naught Fe plus 3 to Fe is equal to, this is overall, E naught Fe plus 3 to Fe plus 2 plus E naught Fe plus 2 to Fe. So E naught Fe plus 3 to Fe, the value is minus 0.04 into 3, that is 3 4s are 12, that is minus 0.12 is equal. Then this value we want to find out, E naught value plus this value is minus 0.88. This value is E naught minus plus minus 0.88. This is 0.12. From that, E naught is equal to, that is minus 0.12 plus this value will go that side, 0.88. So the value is 0.76 volts. So that is plus 0.76 volts. So the answer is option 3. The next question is, in potash alum, the ratio of K plus and SO4 minus 2 ions is. So first of all, what is meant by potash alum? That is K2SO4, Al2SO4 thrice, 24H2O. This is potash alum. It containing potassium ions, 2 potassium ions, that is SO4 minus 2. How many ions are there? SO4, that is total 4 SO4 minus 2 ions, then 2 Al plus 3 ions. So they are asking the ratio between K plus and SO4 2 minus. K plus is to SO4 2 minus, that is 2 potassium ions and 4 sulfate ions. So that 2:4, that is nothing but 1:2 ratio. So the correct option is answer 2, option 2. The next question is, consider the following statements about the solutions formed by mixing two liquids. For example, A option, an ideal solution thus formed obeys Raoult's law throughout the composition range. So we know very well, ideal solution means first must and should be the solution which obey Raoult's law is called ideal solution. In that, throughout composition range is the solution which obey Raoult's law is called ideal solution. So the first option is correct one. In ideal solution, solute and solvent solute, all interactions are same. That is, throughout the composition range is same. So which obeys Raoult's law. But the mixture of chloroform and acetone shows negative deviation from Raoult's law. Once you check that chloroform, that is CHCl3, that is chloroform, and acetone, that is CH3. So here when we added chloroform to acetone, intermolecular hydrogen bonds are developed. Intermolecular hydrogen bonds are developed between chloroform and acetone. So that, for example, this is A, this is B. By combination, these two AB will come. So here AB interactions are stronger than AA and BB interaction. So that it shows negative deviation from Raoult's law. So that option B also correct. Then see, the mixture of aniline and phenol shows positive deviation from Raoult's law. Originally, when we added aniline to phenol, here also intermolecular hydrogen bonds are formed between aniline and phenol. So here also it is A and B. So here by adding it can form AB. So here also AB interactions are stronger than AA and BB. So it also shows negative deviation from Raoult's law. Negative deviation from Raoult's law. Negative deviation from Raoult's law. But they given positive deviation from Raoult's law. So this is wrong statement. So the statement A and B only correct. So the correct option is second option. So dear students, the remaining questions I will explain in next video. So please subscribe my YouTube channel and like and give good comment. Thank you one and all.